This is Algebra 4 Honors Rational Functions and Equations Review. And we're going to start with number 1. So they asked much less. They're asking for much less than I required or what we went over the last few days when we actually started graphing. Much less, okay? So I'm going to show you some shortcuts to graphing today. So the first thing is going to be vertical asymptote. Where do you find it? You look over at the denominator. And you're going to set the denominator equal to 0 and solve. Now I want to go over, from my past experience of teaching this, I want to go over two methods to finding the vertical asymptote, and I'll tell you which one most students make mistakes on. So myself, I would probably set it equal to 0, and whether I did it in my mind or on paper, I would solve. So I add 9 to both sides, and then I take the square root. Well, using this method, it's the method I would personally use. A lot of students make a mistake, and this is what they put, x equals 3. And the mistake is there's a square here. This represents both a positive and a negative answer, so it's plus n minus 3. So where you see it, vertical asymptote, it's x equals 3 and x equals negative 3. The alternative method to doing this is to factor. X squared minus 9 breaks into x plus 3 and x minus 3. What makes this factor equal to 0? X equals negative 3. What makes this factor equal to 0? X equals positive 3. Either method would work as long as you remember the square represents positive and negative 3. Okay, so we've done the vertical asymptotes. Let's go down below. Find the line x equals positive 3 and dot it to represent one vertical asymptote, and the line x equals negative 3 to represent the opposing vertical asymptote. Horizontal asymptote. I have a cheat sheet here for you to review at home. So when you leave class today, feel free to take this. You cannot use this on the test, but it will give you suggestions to how to go about graphing, or how to find asymptotes, both vertical, horizontal, and slant. Okay, so the horizontal asymptote. You're going to see that the degree on top is a 2, and the degree on the bottom is the 2. So when the degree on top, or the highest exponent on top, is the same as the highest exponent on the bottom, you divide the leading coefficients, the numbers in front. In this case, it would be 2 divided by 1. 2 divided by 1 is 2. Go back to the graph. Find the line y equals 2, and make a dotted line going across. Now before I do domain and range, I actually want to graph it. Okay, so for the purpose of going fast, we have a few things that we get to cheat here with. So please do second plus 7, 1, 2. If you don't have a graphing calculator in your desk, go grab one. Parentheses 2x squared and parentheses divided by x squared subtract 9. All right, so we're going to graph this. Once you've plugged it in, please hit graph. Now hit second table. And you can use the cursors to move up and down. And we're going to pull pieces from here and to graph them. If you're a little bit confused, recall that when I originally taught you how to graph rational functions, I had you actually choose x values, algebraically calculate the y values. We're going to use this to give us values right now. So I see 3 sections. I'm going to start with the section off to the left-hand side, and I'm going to look at the x values. So to the left of this vertical asymptote would be negative 4, negative 5, and negative 6. I'm going to choose 2 or 3 values off to the left. So come up here and find negative 4, negative 5, and negative 6. Negative 4 for an x value corresponds with 4.57, and you can see what negative 5 and negative 6 also correspond with. So please graph those 3 ordered pairs at this time. The second section is in the middle. And the second section goes between -3 to +3. It does not include those endpoints of -3 or +3 because they're vertical asymptotes. So I look back here and I see -3 to +3. The reason it says air is because a vertical asymptote occurs at that line or at that x value. So please graph -2, -1, 0, and 1 with the corresponding y value. The third section starts after the line x equals 3. So I'm going to scroll up here. So after 3 I'm going to do 4, 5, and 6. So find 4, 5, and 6 and graph those 3 ordered pairs. Over 4, up approximately 4.5. Over 5 and 3.1. And 6 and 2.6. So I graphed 4, 5, and 6 because I look at the vertical asymptote, which happens to be 3 here. And what are the next 3 numbers to the right? 4, 5, 6. Now hit the word graph. We want the manual graph, or the graph we're creating on paper, to reflect this. So I already have my points. I'm now going to connect those points and have it look like this. Make sure that your graph has arrows as it goes up and also to the left and to the right. On the outside portions of this function, the middle function will come up as high as y equals 0, and then as it goes down it gets closer and closer to the vertical asymptotes but never touches them. Domain and range. Domain describes x values. So, domain and range. Domain, it comes in from, and remember this is x values, so come up here and write x values if you're still a little confused about domain. So looking at this from left to right, it comes in from the left and it goes as far as this first blue wall. So from the left-hand side, this arrow that says it continues to go to the left, never stops, represents negative infinity. Comes in from negative infinity, goes as far as x equals -3. It does not touch negative infinity. It does not touch or cross -3. Then it jumps over the wall and we have the middle section. The x values start at -3 and it goes as far as to +3, never touching any of the start points or end points. Jumps over the last blue wall, starts again on the right side of 3, and goes as far as positive infinity. The range, so I'm looking at the y values, coming up from the bottom and going to the top. This is a little more confusing. I want to come back here. -3s and the +3s have a parenthesis because it does not touch these vertical asymptotes, okay? It approaches but does not touch. So the range, it comes up from negative infinity and it goes up as high as y equals 0. Now at the point y equals 0, is this point right here, is this a vertical or horizontal asymptote at this exact point, yes or no? Does it have a dotted line going through it? Okay, it doesn't. Does it actually touch that point? Put your finger or your pencil or point at the origin. Does your graph go through the origin? Yes, it touches it. Make it into a bracket. It touches it. Comes up from negative infinity. It goes as high as y equals 0 and actually touches that point. Then there's like this dead space. Nothing's happening here. Then it jumps over the wall, y equals 2, and it starts again. And it goes from y equals 2 up to positive infinity. I'd like us to practice both increasing and decreasing. So down below, you're going to add to part C. I'd like you to write decreasing and an area to write the answer. Whenever we describe increasing or decreasing intervals, we're going to use x values to describe them. So think of yourself as biking, and we always describe this going from left to right. So from left to right, on this portion of the graph, from left to right, would you be biking uphill or downhill? Anyone? Uphill or downhill? Going uphill. Whenever we go up, we are increasing. So I go to the section that talks about increasing. And now I have to use an x value to describe this portion of the graph. Well, x values, it comes from negative infinity, and it goes as far as the x value, -3. Now we jump over to the middle. Think of yourself as this time hiking. You're hiking up the hill, then you get to the very top and you're resting. When you're at the very top, you're neither going up or down. You're resting. Then you go down the hill, okay? So, going uphill, you start from, in terms of x values. What x value do you start at? Not y, is what x? -3. And now this is a little trickier. You continue to go upward until you get to the x value, x equals 0. Now at x equals 0, you're at the top of the hill. If you hike Camelback Mountain and you get up to the top and you have a seat and somebody goes, hey, right now are you hiking up or are you hiking down? You'd say neither, you're resting, right? You're not going up or you're not going down. In that case, the same applies for increasing and decreasing. At 0, you're neither going up or down, it's a neither. So we're going to put a parenthesis around the 0 and not a bracket. After 0, we begin to go downward. So we're decreasing from 0 down to the x value of 3. We jump over this dotted line, this vertical asymptote. We start again on the right-hand side here. Your third section starts at 3, and it goes to an x value of +infinity. From previous classes, most students struggled with increasing and decreasing the most. Please talk to your partner about this to make sure they understand or to see if you can get help from your partner.